Let's try another one. For example 6, find the extrema of f of x is equal to 2x minus 3x to the 2/3 on the interval, closed interval from -1 to 3. When it says to find the extrema, we're talking about the absolute min and max values of our particular graph. And what test do I use? What do I use in order to find the absolute minimum and maximum? I need to use the closed interval test, otherwise known as the candidates test. It's called a closed interval test because you need to have a closed interval, and it's called the candidates because candidates are telling you where you can have your absolute minimum and maximum points. And those candidates could possibly be the endpoints of your closed interval and where your derivative is either equal to 0 or undefined. This is assuming that you have a continuous function on that closed interval. Is this thing continuous? Well, the only thing that you should probably be doubtful of or skeptical of is this x to the 2/3 power. But think about this for a second. I'm taking the cube root of a number, and then I'm also squaring it. Is there any number you can't take the cube root of? Cube roots don't work the same way as square roots. You can take cube roots of positives and negatives, it doesn't matter. And then you're squaring that number. We can take the cube root, we can raise any power, a number to the 2/3 power basically. So this is going to be continuous everywhere, so therefore it's continuous on this closed interval. We're good to go. All right, so I'm going to start this process by finding the derivative. F prime of x is equal to 2 minus, let's leapfrog that power down, the 3 times the 2/3, the 3's are going to cancel, and I get 2x to the -1/3 power. All right, let's set that thing equal to 0 so we can find our critical numbers. 2 minus 2x to the, you know what I'm going to do? I'm just going to bring that down to the bottom, x to the +1/3. Now I've got to solve that, and I'm going to solve that by maybe separating these things. I'm going to add this term over to the left-hand side. I have 2 over x to the 1/3 is equal to 2. And then just cross multiply here. And I have x to the 1/3 is equal to 2 divided by 2 is 1. Finally, I cube both sides and I get x is equal to just the number 1. What did we just find there? That is a critical number, which is a possible candidate for a minimum or a maximum value. Do we have any other candidates? Of course we do. We have the two endpoints here at -1 and 3. Is that it? Now there's one more. Did you pick up on it while I was working through this? There's one other candidate, and it is a critical number. Because take a look at this derivative that's right here, especially whenever I put this negative exponent down to the bottom. I'm going to have a place where this derivative is not going to exist right here at 0 if I plugged a 0 in here for x. So f prime of 0 is undefined, which means that it is another critical number. Okay, so here's a question. Before we look at the graph and all of this, see if you can think about what the graph is going to look like at this value right here at f of 0. We have a continuous function, but the derivative is not going to exist there, and it's possibly a minimum or a maximum value. Okay, so we'll take a look at the graph of that if you couldn't figure it out on your own. Of course, you could graph it on your own, but what fun would that be? Okay, so I need to make myself a table of values. Let's see, it was a 2x minus 3x to the 2/3 value. Okay. Good old t-chart. And over here on the left-hand side for my x values, those are going to be all of our candidates, starting with the endpoints, -1 and 3, and in between there are our critical numbers, 0 and 1. Let's plug those into the function, and let's see what is the biggest and what is the smallest. So f of -1, plug -1 in here. Try a 2 times -1 minus 3, -1 to the 2/3 power. Okay, so before you start reaching for your calculator, this -1 to the 2/3 power, let's first square it, and that would make it 1. Take the cube root of 1, that's +1 here, so that's just the number 1. I'm going to have a 2 times negative 1 is a negative 2, minus 3 gives me a negative 5. Negative 5. 0 is easy. It's 0, right? If I plug zeros in there, I get a whole lot of nothing. Plug a 1 in there. Feels like I've done this before. Let's see, 2 times 1 minus 3 times 1 to the 2/3 power gives me 2 minus 3 times 1, basically, because 1 to the 2/3 is still just 1, which is a negative 1. And finally, f of 3. 2 times 3 minus 3 times 3 to the 2/3. Okay, let's see. Can we simplify this a little bit? 6 minus, well, I could do a little bit on this one because they're the same exact base and we're multiplying it. This is to the first, what? This is to the first power, or if you prefer, to the 3/3 power. You're multiplying with like bases, you add the exponents. That would make this a 5/3. 3 to the 5/3. Help us out a little bit. Any? 6 minus 3 to the 5/3 power. Well, do we know if it is either bigger or smaller than any of these numbers here? Well, we know it's not equal to those numbers, but it could be bigger or smaller. Let's see. I'm going to pull out a 4-function calculator. And notice that this is more than a 4-function scientific calculator. It's got 5 functions, maybe even 6. Notice I've already got it typed in here. How convenient. Here I've got 6 minus 3 to the 5/3 power, and we get a negative 0.240-ish. About negative 0.240. Remember, calculus exam, AP calculus exam, they want you having 3 decimal places. All right, now the rest of this, very, very simple. What's the biggest? What's the smallest? Well, the smallest number here is going to be at negative 5, because it is negative. It's smaller than all of the other numbers there. Boop. So this is going to be our absolute min. Scribble, scribble, scribble. There we go. At f of negative 1, which is equal to negative 5. So the minimum value is negative 5 on this closed interval. And then what's the biggest number? Biggest number is, well, all of them are negative except for right here at 0. So that's got to be our absolute maximum. That's kind of sad, isn't it? Biggest number for your graph is actually 0. Abs max. That's not what that says. Max at f of 0 is equal to 0. All right, let's take a look and see what the graph looks like. In particular, we want to see what the graph looks like here. Remember, it was a continuous function, but the derivative did not exist there, and we actually did have a relative maximum at that particular point. I wonder what the graph looks like. Let's see here. So, notice you got yourself a sharp turn right there, right? Well, also think about this is that the derivative right there didn't exist. We're dividing by 0. When dividing by 0, we're going to hit either positive or negative infinity. I say hit as if you're going to get there. But it's approaching a positive or a negative infinity on either one of the sides. We've got our vertical. So sort of approaching a vertical tangent line there, and coming back down. But it's not a vertical tangent line ever. No, as a matter of fact, the derivative would have a vertical asymptote right there. And we have a sharp turn. Okay, so we said our absolute minimum value was right here at negative 5, which we can see is happening, and our absolute maximum right there is at 0, not at this little endpoint here, but right there at 0.